Now we continue our truss analysis, working out the forces in each of the members of this truss from before. We originally worked out the reaction forces which must exist because of this single load we supplied to our truss. We ignored the weight of the truss itself. We used a method of joints to look at this first joint here, and we determined that this bottom member there was in 560 newtons under tension, and this one going up here at that angle was 871 newtons in compression. Next we want to do the next joint. Okay, it's the joint just up there, and analyse that in the same way. So the theory being that that joint is not moving, so therefore all forces acting upon that joint are balanced. We assume that this member can only act either in compression or tension, so it pushes towards the joint or away from the joint, and same with the other ones. We worked out this is compression, so to be compressed it must be pushed in either side from the joints. That means that that member is pushing against the joint. So an upwards force, an upwards to the right force because of that member. If this one's going up, the only other member which has a vertical component is this one, so if that one's going up, this one must be going down, so it's pulling away from that joint, so that must be under tension, pulling that joint down. These two are both pushing that joint towards the right, so this one, this top member, must be pushing it towards the left to stop it all, and pushing against the joint's pushing back in that, it's compression as well. Okay, let's just move that out of the way a little bit. So, as we said, we have a force from that member pushing up. This member must be pulling it down under tension. This force must be pushing it to the left under compression. Let's choose some different symbols this time. Let's remind ourselves that that's in compression. Let's call it C. The force is C, and here the T is the force is T for tension. Now if we just bring this down a bit, I can do a little bit more work on that. Okay, so this 870 Newton force there, we can split that up into components. It's pushing to the right and it's pushing up with the components. Okay, so we might as well do it like that. This force is going this way and that way. The tensile force from the other member is obviously pulling it down. So pulling it down and to the right. And the force in that top member, force C as we're calling it now, is pushing it the other way. So balancing it in vertical motion first, force up equals a force down. This force and that force acting together to go against that force. So C is equal to the components, the horizontal components of those other two members, and the vertical members of those other two forces balance out. Now, let's not write too much. Let's just get straight to it. This angle here is 50 degrees, so that component is going to be the opposite of the 50 degrees, so that is a sine component. So that's going to be 871 newtons sine of the angle. So we know that 50 degrees. So we know that that's the upwards force. The other side, okay, this one, is that going down, it has to completely balance that one, so it's going to be T, and this is also 50 degrees, and that's also opposite, so that's the sine component as well. So if we write that down, it's going to be T sine of 50 degrees is equal to 871 sine of 50. Those two cancels out, and of course we're left with the conclusion that the force in that member that we're calling T has got to be the same as the other one, 871 newtons. Okay. Let's go a little bit further. As we said before, this force here plus that force are opposing C. That joint is not moving, so C equals that plus that. This one is the same as the bottom of the triangle down here, so that's the cos component. Likewise, so that's a cos component. They're both 871 cos of 50 degrees. So 2 lots of those 871 cos of 50 is going to equal force in that top member C. So let's write that down. We have 871 cos 50. Let's use T just to make sure we know what we're doing. Plus T cos of 50 is all going to equal C. Now T is equal to 871 newtons, so let's just skip a step and let's go straight to it. So C is equal to 2 lots of 871 times cos of 50, and that's like 1119.7. Let's round that up. That's 1120 newtons. And just going back to our diagram, that was this top member was 1120 newtons in compression, heading towards the joint, pushing the joint onto the joint that it is, and the one down there below was 871 newtons in tension for that member. So the next lesson, we're going to go to the next joint, which is down here.